All right, this is a classic area volume problem. In 2010, this was a no calculator question. Oftentimes it is a calculator question, and I'll do one of those as well in a minute. But the first thing is R is the region bounded by 2 squared of x, the horizontal line y equals 6, and the y-axis. So here's R. Often the first question is find the area of R. The easiest way to do this is it's the integral of the top one minus the bottom one. So it's the integral from 0, that's where x goes, x is 0, to x is 9, so integral from 0 to 9 of 6 minus 2 square root of x dx. Okay, so we find that integral. This was a no calculator question, so we actually have to find the integral. So this is 6x. This is x to the 1/2 power. So when we do the integral of it, it's going to be x to the 3/2. We add 1 to the power, divide by the power, so 2/3. So it's 2 times 2/3 of this, so it's 4/3 square root of x cubed, evaluated from 0 to 9. 6 times 9 is 54, plus 4/3 times square root of 9 is 3. 3 cubed is 27. And 4/3 times 27 is 36. So it's, oh, this was a minus here. So this is a minus here. So this is going to be 54 minus 36, which is 18. I didn't put minus 0 because 6 times 0 is 0 and square root of 0 is 0, so these just go away. But there was really a minus 0 in here. So that's part A. If this had been on the calculator part, oftentimes they have you find this intersection first, but they gave us this intersection point, so we didn't have to do that. All right, part B. What if we revolve it around the line y equals 7? So this is y equals 6. Y equals 7 is up here. And this is the center of where we're revolving it. So we're taking this region, and it's coming out of the page, around this pin, back through the page. It's going to make one of those blank circle kind of cross sections here. It's going to be a weird kind of a, I don't know, funnel shape with an empty circle in the middle. So it looks like this. This is the cross section if we sliced it perpendicular to the x-axis. And so we'd have this blank circle in here. The way we find this filled in circle of the cross section is it's going to be the area of the big circle minus the area of the little circle. So it's going to be pi times big R squared minus pi times little r squared. And so in this case, the big R is the distance from, it's always the distance from the center to the outer edge. And so that is this, the way we find this vertical distance is top minus bottom. So 7 minus 2 square root of x. 7 minus 2 square root of x. The little r is the distance between where the blank part, the center, and where the blank part ended. So that's y equals 7. This is y equals 6, so it's just 7 minus 6 is the little r. And so this integral is the integral from 0 to 9 of pi times 2 square root of x squared minus pi times, oh, that's not right, 7 minus 2 square root of x squared, 7 minus 6 squared. I'm going to rewrite this. Integral from 0 to 9. I'm going to factor out this pi. You can also write it with the pi factored out. That'll make it a little bit easier. Integral from 0 to 9 of 7 minus 2 square root of x squared minus 1 squared. 7 minus 6 is 1. I just simplified that. And it didn't say to evaluate it, so we just like leave it like that. That's our answer. All right, the last thing. Region R is the base of a solid. For each y, where y is between 0 and 6, the cross-section perpendicular to the y-axis. All right, so this is that stuff we did our very last lesson on this. We're taking a perpendicular cross-section perpendicular to the y-axis. And it says those shapes are rectangles where the height is 3 times the length of the base in region R. So we've got these rectangles sticking out. Really tall rectangles. So they look like this, sticking out. These are very difficult to find the area of if we go horizontally, so we just integrate going up the y-axis instead. We just add up all the areas of each of these rectangles as we go up. So this integral is going to be the integral from 0 to, now we're integrating up the y-axis, so the lowest y we start at is 0, up through 6. It's the integral from 0 to 6, not the integral from 0 to 9, like we were doing when we were going horizontally. The integral from 0 to 6 of, well, we need to find the area of each of these rectangles. And so the area of a rectangle is length times width, or base times height. And this length here is going to be the horizontal distance from here to here. This x value right here is 0. The x value here is going to be the x value of this curve right here. And so we need to solve for x. If y equals 2 square root of x, then y divided by 2 equals square root of x, and x equals y divided by 2 squared. Or if you want to write it, you can leave it like that, or if you wanted to, you could write y squared over 4, squaring that fraction. So that's this x value, and the height of the rectangle is going to be 3 times that. So that's the length. This is the length. The width of the rectangle is 3 times y squared over 4. And so that's our integral, is the integral of these areas. So you can write it just like this. You can leave it as y over 2 squared times 3 times y over 2 squared. You will get full credit if you leave it like that, because it says do not evaluate. Or if you wanted to simplify, you could simplify it as far as saying like the integral from 0 to 6 of, remember that was y squared over 4. When you simplify it, you get 3y to the 4th power all over 16, and that also is fine. Like there's nothing better or worse about either one of these. And we should put dy at the end, because we are integrating up the y-axis to be able to find all these squares. So that's kind of a classic problem. I'll do a calculator one in a second and look at how it's changed in the last few years.